Robotics is one of the most engaging ways to teach programming and problem solving. Today I'm playing with the CrowBot Bolt, a programmable robot car designed for STEAM education. We'll look at its capabilities, its assembly process and how it fits into a robotics learning environment. Let's dive in. The CrowBot Bolt comes as a complete educational kit. It's equipped with a range of sensors, including an ultrasonic distance sensor, an infrared module, and a line tracking system. You can also attach additional external sensors via its two expansion connectors. This makes it perfect for introducing students to concepts like autonomous navigation, obstacle detection, and path following behavior. The main control unit is based on an ESP32, giving you Bluetooth and Wi-Fi connectivity right out of the box. This means you can program the Bolt wirelessly and even integrate IoT concepts into your projects. The box contains an infrared remote controller, but you can also opt for an ESP32 powered Bluetooth joystick remote control. Assembling the CrowBot Bolt is straightforward and is designed to be a hands-on learning experience. The designers of this robot took care to make assembly easy for very young engineers, thanks to the small number of components. Everything fits well and only 4 screws and 2 spacers are required to hold the unit together. I found the included instruction manual clear and easy to follow, making it suitable for students or educators with varying levels of experience in robotics. My only hiccup during assembly is that I managed to break the tips of the acrylic frame where it attaches with the PCB. I used some electrical tape which comes with the CrowBot box to hold everything together, and I think that this actually improves the design because I can now open the case to replace the batteries without having to remove any screws. Let's take a closer look at the built-in sensors and actuators that power the CrowBot Bolt's capabilities. Starting with the sensors, the Bolt is equipped with a removable ultrasonic distance sensor mounted at the front. This sensor measures the distance to obstacles, making it ideal for tasks like obstacle avoidance or proximity-based controls. These sensors also contain RGB LEDs, which can be programmed to change colors for visual feedback. On the underside, there are 4 more tiny RGB LED modules, also programmable, along the 4 corners of the PCB. The Bolt has 2 dual line tracking sensors. These sensors allow the robot to detect and follow lines, making it great for line following experiments or navigating predetermined paths. There are 2 built-in light sensor diodes which can detect ambient brightness levels. This is useful for projects that involve automatic light adjustments or light-seeking behaviors. There's also an infrared receiver module, which you can use with the included infrared remote control to control your CrowBot from a distance, and a buzzer to play tones and provide additional audible feedback. The CrowBot Bolt uses 2 geared DC motors to drive the wheels, which allow for precise movement and control. These motors provide enough torque for smooth motion and handling, even when navigating obstacles or tight turns. Together, these sensors and actuators create a versatile platform, enabling a range of hands-on learning opportunities in robotics and programming. From basic line-following tasks to more advanced obstacle navigation, the CrowBot Bolt offers students a complete toolkit for exploration. One of the standout features of the CrowBot Bolt is its expandability. On the underside of the robot's board, you'll find an I2C connector and a second connector that exposes an analog and a digital pin of the ESP32 microcontroller. These connectors allow for further customization and expansion of the robot's capabilities. You can use these connectors to attach peripherals such as sensors, displays, buttons, and potentiometers. It opens up the potential for more complex projects without needing to modify the core system. With these built-in ports, you can tailor the CrowBot Bolt to specific learning projects, incorporating both simple add-ons and more advanced external modules. The Bolt is programmed using Let's Code, Electro's visual programming platform. This environment is beginner-friendly, using a block-based interface similar to Scratch. It allows students to drag and drop code blocks to create programs for controlling the robot. But for more advanced learners, Let's Code also supports text-based programming using Arduino C or MicroPython. This means that students can start with simple logic and then transition to writing full code, developing both logical thinking and coding skills. The CrowBot Bolt value in education goes beyond the basic robotics. It's an all-in-one platform to teach fundamental concepts of robotics, electronics, and programming. From building circuits to creating algorithms that control the robot's movement, students are able to engage with hands-on learning that blends theory with practice. This makes the Bolt an ideal fit for classrooms or after-school robotics clubs. It's also a great way for beginners at home to explore STEAM topics, as the kit is designed to be user-friendly and adaptable to various levels of expertise. Overall, the CrowBot Bolt is a fantastic educational tool for anyone looking to teach or learn robotics and programming. Its hands-on assembly, versatile sensors, and the Let's Code programming environment provide everything you need to get started with robotics education. Whether you're a student, teacher, or hobbyist, the CrowBot Bolt makes learning fun and engaging. So thanks for watching. If you're interested in learning more about the CrowBot Bolt or how to incorporate it into your curriculum, check out the links in the description below. Don't forget to like and subscribe for more educational tech reviews.